have to go really slow because you've got 8,000 formulas, not necessarily to memorize. You will be able to have a formula sheet, okay? However, some of the formulas I highly, 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 highly encourage you to memorize. And the one that I basically encourage you to memorize are the ones that are in 5.4, along with the multiple angle formulas. Those are the ones that I ask you to memorize. Yeah?
For midterm, are we just going to end up just finishing with 5?
I've thought about that. If for midterm, we're going to go up to 5.3. Okay? Because these formulas here that we're covering are still new. I don't really feel like we're ready to do a major test on them yet, like a midterm examination, okay? That's 10%. Maybe a test on them, but not a midterm. So we're going to be covering everything from 1 through 5.3. That's our focus for the midterm.
Are we going to be able to use like the portfolio?
Yes. I will allow you to construct a pre-calculus portfolio.
So like we could
You may not have problems worked out, but
And
you...
it can go from 1 to 5.3.
1 through 5.3, yes. I'm beginning to feel that the portfolio is a really good helper tool. However, you can only have theorems and definitions, those kinds of things.
So no unit circle.
No. The unit circle you got to have up here.
Formulas are okay.
Right. Formulas are fine. What'd you say?
Are graphs okay?
Graphs are okay. Graphs are okay with me.
As long as it's not worked out.
Okay, let's take the sine to the 4th power of x, and let's go ahead and let's reduce this using its power reducing formula. This is equal to the sine squared of x, all raised to the 2nd power. Okay? Now the power reducing formula says that I can substitute and replace sine squared with 1 minus the cosine of 2u all over 2. So I replace the square of sine with this, 1 minus cosine of 2u all over 2. And now what I'm going to do is I'm going to work this out. Go ahead, yes.
Is it kind of like that because you can also replace sine squared with 1 minus cosine squared?
Yes and no. Because it's a 2u, the answer is no. See, what happened here, Sydney, is even though I'm reducing the power, what's happening is the angle inside is doubling. And I said u, I should be saying x. I apologize for that. So instead of a u here, I should be putting x.
How would we know when to replace sine squared x with that and or with like?
It depends on the kind of problem that you're solving. Sometimes the question will be very direct, Sydney. It will say, rewrite the expression reducing the powers. Sometimes it will be that direct. Other times you have to do it without being told because you want to solve some kind of an equation. And maybe that's the road you want to take to figure out what the solution is. But do you see what happened here? This sine squared, the power went down. This is just a cosine, but what happened is the angle got doubled. That's why it's called power reducing. Now what's going to happen here is I'm going to FOIL out the numerator and square the denominator. So the denominator just becomes 4. And by FOILing out the numerator, I get 1 minus 2 cosine of 2x plus cosine squared of 2x, like that.
Okay, so you brought in, okay, I'm good.
Yep, I wrote this out twice, and I just did the first, outer, inner, last, and that's where I'm getting all of that.
For the first cosine, is it 2x or squared?
This one right here?
Yeah, 2x.
This is just 2 times the cosine of 2x. You'll always see me write the power up above here as a smaller number up above the trig function.
So what's the difference? How do you, like, how would you, why did you have them different when you wrote them down when you just multiplied? Oh, because you added them. I'm good. I think.
Yep.
We are good.
Let me just go ahead and take this right here. No, it's okay. It's okay. I can write this out twice, can I? Because it's squared, right?
Oh, okay, we're good.
And then I do the first, the outer, the inner, and the last. And when you do the outer and the inner, they just add up to 2 times that.
Got you.
That's where that comes from. All right, do you see that this is all divided by 4? So what I'm going to do instead is I'm going to put a 1/4 out front, which is equivalent. Now, while this is nice right here, I now have 1/4 all times 1 minus 2 cosine of 2x plus cosine squared of 2x. While this is nice, the problem here is that I have another square, and I want to power reduce that square.
Wait, okay, never mind. I'm just not going to say it.
No, if you have a question.
Well, cosine 2 squared 2x, doesn't that equal 1? Or is it when the 2 is outside of the cosine?
When the 2 is outside the cosine.
Yeah, and you just have the squared.
Well, if you're thinking of this, the cosine squared of 2x plus the sine squared of 2x is definitely equal to 1. That's true.
Yeah.
That's true.
No, okay, never mind. Just keep going.
Because it doesn't matter what the angle is, so long as you're squaring the sine and the cosine of the same angle, whether it's x or 2x, it's going to be 1 if you're adding them together. Now, I need to power reduce this. Yes, that's exactly right. Even though my angles are doubling, that's okay. I don't mind if my angles double so long as the power goes down. Now, why is that useful in the sciences? Because if I had a physics problem, let's say, that used sines and cosines, and if I had sine to the 4th or sine to the 16th, a computer can calculate the sine of 16x way faster and more efficiently than it can the sine to the 16th power. That's why we do it. That's why we do it. It's all about the modern day age of computation. Okay? So now, look at your little sheet. What's the power reduction formula for cosine squared? 1 plus cosine of 2u all over 2. Now, does everyone see that in this case, the angle that I hear is 2x? Okay? So what's going to happen here is I can substitute this. This is going to be 1 minus the cosine of, does anybody know? 4x over 2. And the reason why is because what happens is that this has to double in the power reducing formula.
Isn't it addition? Yeah, it's addition.
That's what I said. You didn't let me finish. Yep, thank you. Appreciate that. Minus 2 cosine of 2x, 1, and then 1/4. Now, that right there is where I stop, because now the powers, I have no more squares. I have no more 4th power.
So that's your answer?
That is the answer.
How?
Now, let me show you that this is indeed equal to the sine to the 4th of x. Let me show you that that's equal to that. So what I do first is I graph sine of x raised to the 4th power, and that's what the sine of x to the 4th power looks like. And now I graph 1/4 times, what did I have? I had
2 cosine
2 cosine of 2x
plus 1 plus 4x over 2.
plus
Oh, 1
Parentheses, go on.
1 plus cosine
4x.
4x divided by 2 right there. And what just happened here is that the 2 perfectly overlap. They are exactly the same in value. Okay? All right. Oops. All right. Let's take the following. Cosine to the fourth of x. And now let's do some power reduction on this. So this becomes
Cosine squared x.
cosine squared of x, all raised to the second power squared. Now I substitute the inside. So this becomes
1 plus sine. Well, plus sine. 1 plus cos. Oh, goodness.
1 plus cosine 2u. Yes, sir. This just comes from that power reducing formula.
Yeah, but last time I had cosine versus 4x.
We had the first problem that we had was sine to the fourth.
Yeah, but.
Look at the paper he gave us.
Oh, okay, yeah.
Okay. Now, what's going to happen here is I'm going to FOIL the numerator. And I'm just going to square the denominator.
You want to make sure you change this to x.
Yes, thank you again. I did it again, didn't I?
Yeah.
Sorry. That should be a 2x. Thank you. Alright, so if I FOIL, can somebody tell me what I get when I FOIL out the numerator?
1 plus
2 cosine.
2x
2x.
plus cosine squared 2x.
Right. And do you see now that this square is totally different than this 2x right here?
Yes.
All over.
All over 4.
So what I do next is I pull out a 1/4. Okay. And then I use my power reducing again.
Okay, 1 plus cosine
Yes.
over 2.
Over 2.
I'm still confused. Actually, no, I'm not. Actually, yes, I am.
Okay.
I'm confused how you get that. I only knew it because it was on the other problem.
Okay, so you're confused where
Cosine
why this
squared,
becomes a
yeah.
4x right here?
Well, no, I get. How did you get rid of the squared?
How did from the formula?
Which one?
Right there, the middle one on the sheet. See, the formula, Abby, allows me to replace a square cosine
I know,
with 1 plus cosine 2u over 2.
but that's cosine squared u equals that, not
Right.
cosine.
So what is this? This is the cosine squared of 2x, right? Let's just go ahead and let u equal 2x.
Okay.
Well, if I let u equal 2x,
No,
then the cosine squared of u equals 1 plus cosine of 2u all over 2.
Right.
Now let's replace. What was u equal to?
2x.
2x. So this becomes 2 times 2x.
I get it.
So it becomes 4x. So what happens is whatever the angle is on the inside, it effectively doubles that angle on the inside.
Gotcha. You're good. Just being slow today.
Yeah, it's okay.
So that's just, you just leave that as your answer?
I leave that as my answer. Yep. Okay.
I'm so glad it's Friday. Yeah.
How are we doing?
1 plus cosine. Oh, no, oops. Okay. Yeah, okay.
We just started.
4, 3x
Mhm.
equals.
Yep, we finished that one.
Yeah.
10
What about the 3?
to the second 1/3? No.
So this just
Would it still be
becomes
3?
It's still 3.
But once you multiply by 2, then you get the square by 2, you get 9.
That square has no effect on the angle inside. It squares the tangent.
Oh.
Okay,
See,
then why do you have it around the 3x?
I have this right here surrounding the tangent squared of 3x.
Of 3x.
So this is the square of the tangent squared.
This is around the 3x. Okay. I think
See-
I understand. But I don't get why we would have it outside with the 3x. Because then I feel like you would have to do like tan 4 to the 4th.
See, this is the tangent. This is the tangent of 3x. Now, if you square the tangent of 3x, the square has no effect on the 3x. Why? Because the 3x is inside the tangent.
It's part of the expression.
Got you. Okay. Yeah,
The square can only affect the tangent itself.
Okay.
It can't affect what's inside the tangent.
Do something about it, you'll get it.
I will, but it's...
So that's why you have to be very careful. So that's why it would not become the tangent squared of 9x squared. Okay?
Uh-huh.
You got to think about this idea of you've got a purse, and inside the purse you have a little baggie, and inside the baggie no, I'm serious. Think about this. You have a purse, and inside the purse you have a little baggie, and in the baggie you have an Oreo cookie, right? Okay? Now, if you take, now let's pretend everything's watertight, right? Let's pretend everything's watertight. You take the bag, the purse, you dip it in water. Is the Oreo wet?
No.
No, the water has no effect on the purse. Why? Because it's tucked away safely, nice inside the purse, inside the baggie, right?
Got you.
Right? I'm trying to just make a parallel here, okay? So the square here has no effect on the 3x because that 3x is tucked away nice and safe within inside the tangent.
Got you.
Okay? All right, that's a long about way of coming back to where we need to be. That's okay. All right, so according to my power reducing formula, this becomes 1 minus the cosine of what?
6x.
6x over 1 plus the cosine squared.
Wow. So then,
So now what I do is I FOIL out both the numerator and the denominator.
so 1 plus, no way. Minus cosine. No, I don't know. Forget it.
Okay.
Okay. So I get 1 minus 2 cosine 6x plus cosine squared 6x in the numerator.
Now you have to do the cosine squared.
Now we've got to power reduce the cosine squared. Okay.
Wait, can't you call? Never mind. No.
Can't divide them out.
No.
Okay.
Not the.
So this becomes in the numerator 1 minus 2 cosine 6x plus 1 plus cosine
Well,
over 2. 1 plus 2 cosine 6x plus okay, Seth and Joshua. Come on now. Alright, so we get this right here. Do you have any questions how I went from this part right here to this part right here?
I think I'm good.
Okay. Now, there is something we can do to simplify this, and it's going to be nice. I want to get rid of this over 2 because a fraction above a fraction just looks nasty. So what I'm going to do is I'm going to multiply the top by 2 and the bottom by 2. Bless you. I'm going to distribute that 2 in the numerator. So what happens here first, Seth, is this is 1 times 2, so that's 2, minus 2 cosine 6x times 2. What does that become? Minus 4 cosine 6x. Plus, and now this is the whole reason why I did it, by the way, 2 times this is what? 1 plus cosine 12x. All over 2 plus 4 cosine 6x plus 1 plus cosine 12x. Is there anything left in the numerator that can be combined as a like term? 2 and 1, as in the denominator. So now we're ready for our final answer. Our final answer is 3 minus 4 cosine of 6x plus cosine of 12x, all over 3 plus 4 cosine of 6x plus cosine of 12x.
Oh.
Yeah. That 3 comes from the fact that 2 and 1 are like terms. And that gives us the solution.
So that's it.
And that is it.
You leave it like that.
You leave it like that. You leave it like
This is
that.
so sad. Can't borrow anymore now.
Wow.
Open your books to page 413. The homework tonight, this weekend, is numbers 43 through 52 all. I want you to use the rest of the class period to work on that. All right, God bless you, wherever you are.